Imagine you had a spaceship so fast that it could travel 1 light year every second. Sounds impossible. The fact is, you can never fly out of the universe. It's not that the spaceship isn't fast enough. It's not that the fuel isn't enough. The universe simply didn't leave an exit for you. When I checked the data and came to this conclusion, to be honest, I felt a little cold down my spine. The longest traveling probe in human history, Voyager 1. It was launched in 1977. Almost 50 years ago, but so far, it has traveled only around 0.002 light years. Its current speed is about 17 kilometers per second, and yet it is already one of the fastest objects ever created by humanity. Now imagine our hypothetical spaceship, one that can travel 1 light year in just 1 second. This isn't simply a difference in speed, it's almost a difference between 2 species. And there's another interesting fact. Last year, astronomers used powerful telescopes to observe one of the most distant stars ever seen by humanity, MOM-Z14. Its light traveled for billions of years before reaching us. Now imagine our hypothetical spaceship crossing that distance in just 1 second. Compared with that, the entire journey of humanity's most powerful space probes would look like almost nothing. Honestly, the more I look into topics like this, the more I feel that our obsession with speed is worth questioning. I always thought if we became fast enough, we could solve every problem. But the next few truths will completely destroy that idea. Imagine you press the launch button the first second. You've already passed the edge of the solar system. Jupiter, Saturn, Neptune, all those names you heard as a child flash behind you. The 4th second, you pass a star, one humanity has known about for generations. You keep going, and in about 27 hours, you have crossed the entire Milky Way. Billions of stars reduced to a glowing band behind you. You might think, so what's the big deal about the universe? That's what I thought at first. But then, 3 years later, you are already unimaginably far beyond the planets of our solar system. 16 years later, you have traveled far beyond the structure of our own galaxy. One of the largest structures humanity can imagine, billions of light years across, makes our entire Milky Way look like a speck of dust. Then, after roughly 3,000 years, you finally reach what we call the observable universe. Billions of light years across. 3,000 years sounds like the end. But this is exactly where things become strange. The observable universe is not the edge of the universe. It is simply the region of space whose light has had enough time to reach Earth. Think of a fish inside a giant aquarium. The fish sees the glass and assumes the glass is the entire world. But imagine the fish somehow escapes the tank. Would there be a sign outside saying, "This is where the universe ends"? Of course not. And that is basically our situation. The boundary we see may simply be the boundary of what we can observe. And beyond it, there could still be more. That is the first truth. What you think is the edge may simply be someone else's beginning. Now comes the second truth. I looked at the measurements used by the scientific community. The European Space Agency's Planck satellite made extremely precise measurements of the structure of the universe. The final results indicate that, on the largest scales, the universe is remarkably close to flat. The uncertainty is extremely small, and in physics, a universe that is very close to flat can be consistent with an enormously large universe, possibly even one with no edge at all. That means the moment you think you've reached the edge, there could still be another sky ahead of you, filled with stars you have never seen, more galaxies, more darkness, more unknown. It's not that the road is simply very long. It's that the road may never end. And now comes the third truth. This is perhaps the most disturbing one. The universe isn't just huge, it is expanding, and that expansion is accelerating. According to Hubble's law, the farther away a galaxy is, the faster the distance between us, and it tends to increase. Planck measurements put the expansion rate at roughly 67 kilometers per second per megaparsec. Different methods give slightly different values, but the direction is the same. And beyond certain enormous distances, the expansion of space can increase the separation between us and distant regions faster than light could cross that growing distance. This does not mean galaxies are locally breaking the speed of light. Something much stranger is happening. Space itself is expanding. Relativity limits the motion of objects through local space, but it doesn't impose the same speed limit on the expansion of space itself. So imagine this. You are running forward inside an elevator, but the elevator is accelerating backward. You run harder. The elevator moves backward even faster. You think, I'm moving forward, but the distance between you and your destination keeps increasing. The harder you try, the more desperate it becomes. The universe has given you a physical law you cannot simply outrun. But there is another possibility. What if the universe is finite, but has no edge? It sounds impossible. But think about the surface of Earth. You can keep traveling east along the equator, and you will never reach an edge. Eventually, you could return to where you started. Some cosmological models allow space to have a similarly strange structure. You could travel billions of light years and still never encounter a wall. No boundary, no door, no exit, just more space. And if the universe really had this kind of structure, you could travel for thousands of light years. And one day, when the surrounding light has faded, you might look up and see a familiar shape. A galaxy, a sun, and that tiny blue planet, Earth. You traveled thousands of light years, only to discover that you have somehow returned. So the more I look into this, the more I realize something. The real problem was never that we weren't fast enough. The idea of simply flying out of the universe may not even make physical sense. The universe isn't a box filled with stars, with more empty space waiting outside for you to break into. The universe is space, time, matter, energy, and the physical laws that define everything we know. So asking, what is outside the universe, may be like asking, what is north of the North Pole? The direction itself may not exist. You can't escape the universe, because perhaps there is no outside to escape into, and the most distant light we can see has traveled for billions of years before reaching our eyes. When that light began its journey, the source was in a very different location from where it is today. So you may never catch it. You may never see that source as it was when the light began its journey. Even if your spaceship were fast enough, you still couldn't simply catch the original location, because space itself has changed. And that is one of the strangest mysteries of the universe. There may be a thin door in front of us, but beyond that door could be eternal darkness and eternal unknown. And every time I look at information like this, I find myself asking, why are humans still trying? We know that door may never open. We know we may never reach the final answer. And yet, teams of scientists around the world continue working for decades just to understand a little more about the unknown. Maybe the answer is simple, because the question itself matters. We don't need to know that we can reach the answer to ask the question, because without questions, there is no exploration, and without exploration, there is no reason to look beyond our tiny blue planet. Maybe this is what makes humanity different. We may never escape the universe. We may never find its edge. We may never know what lies beyond everything we can observe. But every time we look into the darkness, we discover something we didn't know before. And maybe that is enough, because the universe doesn't need to have an exit for humanity to keep searching for the door. And perhaps the greatest mystery isn't what lies outside the universe. It's why we keep searching, even when we know there may be no way out.